Okay, this is section 3.4, solving rational equations and radical equations. So we're looking at solving two new types of equations. Rational equations. Definition. A rational equation is an equation that has a variable in a denominator. Okay? Variable in the denominator. Having a number in the denominator is not enough to make it a rational equation. We must have a variable in the denominator. So we have dealt with equations with fractions in the past. We cleared our fractions by multiplying by a common denominator, typically the LCD. We will do the same thing here. But remember, since we have a denominator with a variable, the LCD will also contain a variable. But when using the multiplication principle, we were not supposed to multiply both sides of the equation by 0. Since we're multiplying by an expression that contains a variable, we do not know whether or not we are multiplying both sides of the equation by 0. Because remember, if you knew what the value of the variable was, you could just tell us the solution. So when you're multiplying an equation by an expression that contains a variable, you have to do this. Warning. When multiplying an expression that contains a variable, you must check for extraneous solutions. Okay, with rational equations, you must check for extraneous solutions. So this is our first type of equation, which you must actually check your answers to be sure they work. Now, if you've made a mistake, that also won't work. So we need a way to distinguish between a solution that's an extraneous solution as opposed to we've simply made a mistake. So determining extraneous solution from an error. Okay, when an extraneous solution fails to work, it fails to work in a special way. First, when checking whether or not a solution is an extraneous solution, always check in the original equation. Okay, never check in a derived step. So always go back to the original equation and plug in the number. An extraneous solution is a value which, when substituted into the original equation, makes one or more denominators equal to 0. That's how you know it's extraneous. Okay, it makes one or more denominator equal to 0. Now, if it doesn't work, if your value doesn't work without making a denominator equal to 0, then that's an error. Extraneous solutions in rational equations makes a denominator equal to 0. So if the value does not work without making a denominator equal to 0, then the value is an error, and you need to recheck your work. Some examples. Solve for x. Simplify your answers. Do not use mixed numbers or decimals in your answers. Here's our first one. I have x over x plus 2 equals 1 over x. Remember, in order to find the LCD, you have to factor all the denominators. They are factored. And then the LCD consists of the product of all the different factors you see from the denominators. So our LCD is going to be x times x plus 2. So we're going to multiply both sides of the equation by x times x plus 2, which I can also write as x times x plus 2 over 1 to clear fractions. Okay, remember, it still amounts to multiply each numerator by factors from the LCD that do not appear in its denominator. So in this example, we're going to show you why you actually end up doing that. So remember, you would multiply each numerator by factors from the LCD that are not in its denominator. So here I am multiplying both sides of the equation by x times x plus 2. Notice the denominator that has x plus 2, they cancel. And on the right, the denominator that contains x's, the x's cancel. So I'm just left with x times x, better known as x squared, is equal to 1 times x plus 2, or x plus 2. So again, it amounted to I multiplied each numerator by factors from the LCD that do not appear in its denominator. Okay, now one like this, where a fraction equals a fraction, students will just say, can I cross multiply? Yeah, that's really what you did. X squared, x plus 2. Okay, I'm going to have an x squared, so I want it set equal to 0. I want to move everything to the left. So I'll have x squared minus x minus 2 equals 0. The only factors of 2 are 2 and 1. To get a minus 1 in the middle, the 2 has to be minus. So I have x minus 2 times x plus 1 equals 0. Setting each factor equal to 0 gives me x is 2 or negative 1. Okay, now when you check, you can actually kind of check mentally. Remember, you're just worrying, does it make a denominator equal to 0? If x is 2, I don't have 0 in the denominator. If x is negative 1, I don't have 0 in the denominator. So they both checked out. So my solutions are 2 and negative 1. Now again, if you actually go through the pure agony of checking and it doesn't work, then that means you've made a mistake. Remember, an extraneous solution will make one or more denominators equal to 0. Here's our second one. I have x over x minus 2 minus 2 over x plus 2 is equal to 3x plus 2 all over x squared minus 4. Okay, now notice, the last denominator, the x squared minus 4, factors as the first two. So that's my LCD. So my LCD is x minus 2 times x plus 2. Now remember, when I'm clearing your fractions, multiply each numerator by factors from the LCD that do not appear in its denominator. So this one doesn't have x plus 2, so I'll have x times x plus 2 minus 2 times x minus 2, and since this number has both, you just write down the numerator. So x times x plus 2 minus 2 times x plus 2 is equal to 3x plus 2. Okay, we have to distribute on the left. We'll have x squared plus 2x minus 2x minus 4 is equal to 3x plus 2. Okay, on the left, the 2x minus 2x adds up to be 0. So I'll have x squared plus 4 is equal to 3x plus 2. Okay, again, I've got an x squared. Let's move everything to the left. So I'll have x squared minus 3x plus 2 is equal to 0. Okay, I want to factor. Again, the factors of 2 are 1 and 2. Since that's a plus and that's a minus, they'll both be minus. So x minus 2, x minus 1 equals 0. Setting each factor equal to 0. X minus 2 gives me 2, and x minus 1 gives me 1. Now let's check them. Note if x is 2, right away that first denominator works out to be 0. So it's extraneous. If x is 1, none of the denominators are equal to 0, so 1 is okay. So x equals 2 is eliminated because it made a denominator equal to 0. Our only solution is x equal 1. Okay, don't list the extraneous solutions. Now remember, in order to be an extraneous solution, it must first appear as a solution. Because some of the questions on the test might ask you true or false, such and such a number is an extraneous solution. You still have to actually go through the work and see if does that number appear as a solution, and then does it make a denominator equal to 0. Number 3, I have 3 over x plus 1 minus 2 over x minus 3 is equal to negative 8 over x squared minus 2x minus 3. Again, the last denominator factors as the first two. Factors as x plus 1 times x minus 3. So that is my LCD. Okay, now again, when we clear fractions, multiply each numerator by factors from the LCD that do not appear in its denominator. So I'll have 3 times x minus 3 minus 2 times x plus 1 is equal to negative 8. That's what's going to happen when I clear fractions. Okay, on the left-hand side, we need to distribute. So I have 3x minus 9 minus 2x minus 2 is equal to negative 8. On the left, combine your terms. 3x minus 2x is x, and negative 9 minus 2 is negative 11. So I have x minus 11 equals negative 8. Add 11 to both sides. I get x is equal to 3. And then we check, does it make a denominator equal to 0? Well, if x is 3, this denominator is 0. So x equal 3 has to be eliminated. It was our only candidate for a solution, and it doesn't work. So we have no solution. Okay, no solution. And again, when there's no solution, say no solution. Don't say false. Say no solution. Number 4. I have x over x plus 2 plus x over x minus 3 is equal to x squared plus 6 over x squared minus x minus 6. Okay, once again, it looks like the last denominator factors as the first two. So that is my LCD. Again, when we clear fractions, multiply each numerator by factors from the LCD that do not appear in its denominator. So I'll have x times x minus 3 plus x times x plus 2 is equal to x squared plus 6. On the left-hand side, it looks like I have to distribute. So I'll have x squared minus 3x plus x squared plus 2x is equal to x squared plus 6. Combine terms on the left. X squared plus x squared gives me 2x squared. Minus 3x plus 2x gives me minus x. So I have 2x squared minus x is equal to x squared plus 6. Okay, once again I have the x squared. Let's move everything to the left. So 2x squared minus x squared will be just 1x squared minus x minus 6. So I have x squared minus x minus 6 equals 0. Factor. It factors as x plus 2, x minus 3, giving me x is negative 2 from the first factor, x is 3 from the second factor. If I check these, x equal negative 2 makes the first denominator equal to 0. X equal 3 makes that denominator equal to 0. They both made at least one denominator equal to 0. So both of them are extraneous. So neither one works. That means we have no solution. Okay. There's no way of knowing in advance whether or not they will work. All you know is that with a rational equation, if you have a variable in the denominator, you have to check your solutions. Let's move on to the second type of equation, radical equations. Definition. A radical equation is an equation in which a variable appears under a radical. So that means the variable is part of the radicand. So it's not enough just to have a radical in the equation. You must have a variable as part of the radicand in the equation. So, some examples. X plus the square root of 5 equals 7 is not a radical equation, since there is no variable under a radical. There is a number, but no radical. This is actually a linear equation. To solve it, you would just subtract the square root of 5 from both sides. So you'd get x is equal to 7 minus the square root of 5. Number 2, 5 plus the square root of x equals 7. That is a radical equation. There is a variable as part of a radicand. Remember, that's what you need in order to have a radical equation. Now, how do we solve these? So, the principle of powers. It says if an equation a equals b is true, then a to the n equals b to the n is also true for any value n not equal to 0. Remember, if you take anything to the 0 power, you'd have 1. So you'd have 1 equals 1. Now note, the square root principle is a special case of the principle of powers with n equal 1/2. Remember, you take square roots, and according to our fractional exponents, way back in section R.7, the 1/2 is a square root. So we've actually done the principle of powers in a very special case. Now, method for solving radical equations. Step 1, isolate one of the radicals. And by saying isolate one of the radicals, be warned that you could have more than one radical in the equation. Okay, typically the most I will give you is 2. The book loves to give you like 3, 4, 5 radicals in the equation. That's just so unrealistic. Step 2, use principal powers to eliminate the isolated radical. If you have a square root, then you would square both sides. If you had a cube root, you would cube both sides, and so on. Step 3, repeat steps 1 and 2 until all radicals have been eliminated. Now typically, the number of times you have to repeat steps 1 and 2 is equal to the number of radicals in the equation to start with. So after you've completed step 3, you should have an equation that has no radicals. You should have something that we know how to solve. So step 4, you should now have an equation that you can solve. Solve it. So after you work, you get some numbers. Now step 5, you have to check for extraneous solutions. Now again, when you check, always go back to the original equation. Now with the rational equations, we knew an extraneous solution made a denominator equal to 0. Now how can we tell, with radical equations, how can we tell if a solution is extraneous as opposed to an error? So determining if the solution is an extraneous solution. Okay, so right now you have a value that is going to be extraneous, let's say. So when checking whether or not a solution is an extraneous solution, you will go back to the original equation. Remember, always go back to the original equation. For a radical equation, an extraneous solution is a value that would work. Remember, it's not working right now, but that would work if you changed one or more signs in the original equation. Now, quite frankly, I've never had a situation yet where an extraneous solution you had to change more than just one sign to make it work. So if it turns out no matter how many signs you change it doesn't work, that's an error. For an extraneous solution, all you need to do is typically just change one sign. Let's try some examples. Solve for x, simplify your answers, do not use mixed numbers or decimals in your answers. So the usual directions for solving an equation. Here's our first one. I have the square root of 3x minus 5 is equal to 2. The entire radicand is 3x minus 5. Okay, step 1 was to isolate the radical. It is isolated. So it's a square root. I need to square both sides. So I'll have the square root of 3x minus 5 squared is equal to 2 squared. Okay, on the left-hand side, the radical disappears. And on the right-hand side, I get 2 squared, which is 4. So I'm going to have 3x minus 5 is equal to 4. So we have a nice little linear equation. Okay, add 5. I got 3x is equal to 9. Divide by 3, x is equal to 3. Okay, let's check it. So to check x equal 3. So I want to know, does the square root of 3 times 3 minus 5, does it equal 2? See, 3 times 3 is 9. Square root of 9 minus 5, does that equal 2? 9 minus 4 is 9 minus 5 is 4. Does square root of 4 equal 2? Yes, 2 equals 2. So x equal 3 is our solution. Let's try number 2. I have 3x minus 2 to the 1/3 power is equal to negative 2. Okay, the radical is already isolated. Remember, a 1/3 power is a cube root. So we're going to cube both sides. So 3x minus 2 to the 1/3 cubed is equal to negative 2 cubed. Okay, notice if you do the laws of exponents, 1/3 times 3 is going to give me 1. So I have 3x minus 2 is equal to negative 8. Add the 2. So 3x is equal to negative 6. Divide by 3, x is equal to negative 2. And now let's check it out. So I'm going to have 3 times negative 2 minus 2 to the 1/3 power. Does it equal negative 2? Okay, 3 times negative 2 is negative 6. So negative 6 minus 2 to the 1/3. Does that equal negative 2? Okay, negative 6 minus 2 is negative 8. Is the cube root of negative 8 negative 2? Yes, it is. So x equals negative 2 is our solution. Typically, you don't have to check the odd roots. It's really just the even roots that you have to check. There's actually a reason why you can avoid checking the odd roots, and you must check the even roots. Number 3, I have the square root of 3x minus 3 plus 8 equals 2. The 8 is not part of the radical. So in order to isolate the radical, we have to subtract 8 from both sides. So I'll have the square root of 3x minus 3 is equal to negative 6. Okay, the radical is now isolated. It's a square root. Square both sides. So the square root of 3x minus 3 squared is equal to negative 6 squared. Okay, on the left I get 3x minus 3. On the right, negative 6 squared is positive 36, right? Minus times minus. Okay, it's linear now. Add 3 to both sides. 3x is equal to 39. Divide by 3, x is 13. And now we check. Go back to the original equation. So we're going to have the square root of 3 times 13 minus 3 plus 8, does it equal 2? Okay, under the square root, 3 times 13, I get 39. So square root of 39 minus 3 plus 8, does it equal 2? Okay, 39 minus 3 gives me 36. Square root of 36 plus 8, does that equal 2? Square root of 36 is 6. Does 6 plus 8 equal 2? No, it doesn't. But do notice, if this 6 were to change its sign and be a negative, it would work. So that's how we know it's extraneous as opposed to an error. But anyway, x equals 13 did not work. So there's no solution. Now the eagle eyes among you may have noticed way back up here in this step, I'm taking a principal square root because of that symbol and getting a negative number. Remember, by definition of the principal square root, that's not supposed to happen. So if you notice that right away, back up here you could have said no solution. But if you didn't notice it, you go through all the work and you do what you're supposed to do, you do your check, you discover that there is no solution anyway. Number 4. The square root of 3x plus 6 minus the square root of 2x minus 4 equals 2. Okay, we have 2 radicals. We need to isolate one of them. It doesn't matter which one you isolate. I like to move the one that's got the minus sign to the other side. So I'm going to isolate the square root of 3x plus 4 by adding the square root of 2x minus 4 to both sides. So I have the square root of 3x plus 6 is equal to 2 plus the square root of 2x minus 4. Okay, my isolated radical is a square root. Square both sides. So I'm going to have the square root of 3x plus 6 squared is equal to 2 plus the square root of 2x minus 4 squared. Okay, the left-hand side is going to become 3x plus 6. On the right-hand side, it's like squaring a binomial. You square the first term, twice the product, and square the last. Now, if you can't do that quickly, you can just do 2 plus the square root of 2x minus 4 times 2 plus the square root of 2x minus 4 and FOIL it out. So anyway, the left-hand side is 3x plus 6. Okay, now this, square the first term. So 2 squared is 4. Keep the sign that's in the middle. Okay, I want twice the product. The product is 2 times the square root of 2x minus 4. Double the 2, you get 4 times the square root of 2x minus 4. Then square the last. Okay, when you square the square root of 2x minus 4, all you get back is 2x minus 4. And again, if you have to do 2 plus the square root of 2x minus 4 times 2 plus the square root of 2x minus 4 and FOIL it out, you'll get the same thing, and it won't take that much longer. Okay, on the right-hand side, I need to combine some terms. 4 minus 4 is going to be 0. Remember, this 4 cannot combine with that 4 because of the square root. So anyway, 4 minus 4 gives me 0. So I've got 3x plus 6 is equal to 4 times the square root of 2x minus 4 plus 2x. Okay, I still have a radical. I need to isolate it. So to isolate it, let's first subtract 2x. So I'll have x plus 6 is equal to 4 times the square root of 2x minus 4. You know, technically to isolate the radical, I should divide by 4, but I don't want to do that. That's going to create a fraction. So I'm going to go ahead and square both sides now as they sit. And I'll just have to remember to square the 4 as well. So I'm going to square both sides. X plus 6 squared is equal to 4 times the square root of 2x minus 4 squared. Okay, remember, we're squaring a binomial again. We've done this so many times, hopefully you can do it quickly. Remember, square the first, twice the product, square the last. So I'll have x squared plus 12x plus 36. Again, if you have to do x plus 6 times x plus 6 and FOIL it out, that's fine. When I square the right-hand side, don't forget to square the 4. I'll have 16 times 2x minus 4. So x squared plus 12x plus 36 is equal to 16 times 2x minus 4. Okay, on the right-hand side, I have to distribute the 16. So that'll give me 32x minus 64. So I'll have x squared plus 12x plus 36 is equal to 32x minus 64. Okay, I do have that x squared. Let's move everything to the left. Subtract 32x, add 64. So when I subtract 32x and add 64, I'll have x squared plus x minus 20x plus 100. This is really x minus 10 squared, isn't it? Or x minus 10 times x minus 10 if you prefer. Taking square roots of both sides, I get x is 10. Or if you were to set each factor equals 0, you'd also get x equals 10. And now we have to check. Okay? After all this work, we have to go back and check x equals 10. So we go back to the original problem and let x equal 10 and see what happens. Wouldn't it be awful if it didn't work? So we're checking x equal 10. Square root of 3 times 10 plus 6 minus square root of 2 times 10 minus 4, does it equal 2? Okay, for the first one, I'm getting the square root of 36, and for the second one, I'm getting the square root of 16, right? 3 times 10 is 30, plus 6 is 36. 2 times 10 is 20, minus 4 is 16. Square root of 36 is 6, square root of 16 is 4. So 6 minus 4 equal 2? I believe it does. So x equal 10 did in fact work. So that's our solution. X equals 10. Okay, example number 5. The square root of x plus 6 minus square root of x minus 2 equals 2. Okay, once again, we need to isolate the radical. I'm going to isolate the square root of x plus 6 by adding the square root of x minus 2 to both sides. So that'll give me the square root of x plus 6 is equal to 2 plus the square root of x minus 2. And now we square both sides. So the square root of x plus 6 squared is equal to 2 plus square root of x minus 2 squared. The left-hand side becomes x plus 6. Okay, on the right-hand side, square the first term. Okay, I want twice the product. The product is 2 times the square root of x minus 2. Double the 2 gives me the 4. 4 times x minus 2. And when you square the last, the radical goes away. Okay, I can combine some terms on the right. I can do 4 minus 2 is 2. So I'll have x plus 6 is equal to 2 plus 4 times the square root of x minus 2. I now need to isolate the square root of x minus 2. So let's see. Subtract x, subtract 2. X minus x will be 0, and 6 minus 4 will be 4. So I'll have 4 equals 4 square root of x minus 2. Okay, this time it's worth dividing by the 4, so divide by 4. And I'll have 1 equals the square root of x minus 2. Okay, I have an isolated square root, square both sides. 1 squared is 1, and on the right, squaring makes the radical go away. An incredibly simple equation. Just add 2 to both sides. 3 is equal to x. So now we check it out. So we go back to the original problem, let x equal 3. So I'll have the square root of 3 plus 6 minus square root of 3 minus 2, does that equal 2? Okay, 3 plus 6 is 9, and 3 minus 2 is 1. So square root of 9 minus square root of 1, does that equal 2? Okay, the square root of 9 is 3, square root of 1 is 1. 3 minus 1 equal 2? Yep. So our solution is x equal 3. Let's take a look at one more radical equation. The square root of 9 minus x is equal to x plus 3. Okay, there is only one radical. It is isolated. So we need to square both sides. So square root of 9 minus x squared is equal to x plus 3 squared. We're squaring a binomial again. The left-hand side is 9 minus x. The right-hand side is x squared plus 6x plus 9. Remember, square the first, twice the product, square the last. Okay, because it is a quadratic, I'm going to move everything to the right. Again, I don't like negative x squares. So subtract 9, add x. So I have 0 is equal to x squared plus 7x. On the right, I can factor out an x and have 0 equals x times x plus 7. Okay, setting each factor equal to 0, I get 0 or negative 7. So x equals 0 or negative 7. and then I got to check. So let's check x equals 0. So going back to the original problem, let x be 0. Square root of 9 minus 0, does that equal 0 plus 3? Okay, 9 minus 0 is 9, so square root of 9 equals 3. I believe it does, since square root of 9 is 3. So x equals 0 checks out. Now we're going to check x equals negative 7. Again, going back to the original problem, square root of 9 minus negative 7 equal negative 7 plus 3. Okay, 9 minus 7 is going to be negative, it's going to be 16. Square root of 16 equals negative 4? No, it doesn't. Square root of 16 is 4. But notice, if this were to change its sign, it would work. So x equals negative 7 is extraneous. Our only solution is x equals 0. Let's try some word problems. Okay, this is called a work problem. Not work in the sense of physics, but work in the sense of we must accomplish a task. So Bill can mow a lawn in 30 minutes, and Sam can mow the same lawn in 45 minutes. How many minutes will it take the two boys to mow the lawn if they work together? So our goal is to get one mowed lawn. Our solution. We let x equal the time together. We convert to unit time. That is, how much can each boy do in 1 minute? So it's kind of like we're trying to figure out how much of a lawn per minute can they mow. So it's kind of like distance equals rate times time. You know, notice it takes Bill 30 minutes to mow the lawn. So in 1 minute, he's 1/30th of the way done. So just flip it over. Sam can mow the lawn in 45 minutes. So in 1 minute, he's 1/45th of the way through. So Bill works at a rate of 1/30th of a lawn per minute, and Sam is working at a rate of 1/45th of a lawn per minute. Okay, so you take the individual time and flip them over. Okay, now if you're doing distance equals rate times time, that's our rate. So since they're working together, we're going to add. And remember, they're working for a total of x minutes together. So our equation is going to be 1/30th x plus 1/45th x is equal to 1. The 1 stands for one completed task, in this case, one mowed lawn. Okay, so again, notice, we inverted the eventual times, multiplied by the time together, and added, and set it equal to 1. Okay, my LCD for 30 and 45 is 90. So I multiply everything by 90, including the 1. See, 90 over 30 is going to be 3, and 90 over 45 is going to be 2. So I have 3x plus 2x equals 90. 5x equals 90. Lo and behold, x is 18 minutes. So it'll take them 18 minutes if they work together. Now, again, the work problem illustrates a rather general procedure. So the general procedure for solving work problems. Again, work in the sense of we must accomplish a task. Step 1, invert the individual times. Whatever they are, just flip them over. So that you have to be given fractions. If they're decimals, you got to convert them to fractions. Step 2, multiply the inverted times by the total time working together. Step 3, if the individuals are working together, add the result of step 2. In this case, they're both trying to accomplish the same task. If the individuals are working against each other, subtract the result of step 2. The classic example of two things working against each other is if you're filling and draining a sink at the same time. Step 4, set the result of step 2, or excuse me, set the result of step 3 equal to 1 and solve. Remember, the 1 stands for one completed task. Okay, let me show you something quick and dirty on the calculator. Okay, remember the Bill and Sam, it took them 18 minutes together. This is what you can do on the, when you're given the individual times as numbers. Remember, it took Bill 30 minutes, so do 30, x to the minus 1. Plus, because they're working together, remember the x to the minus 1 flips it over. 45, x to the minus 1, that was Sam. And then just press equal, or enter, I guess I should say. Okay, now that's the flipped over time. So do x inverse, so notice it's flipping over the final calculated result, and it's 18. Okay, so this works when you're given the individual times as numbers. Okay, let's try another one. A sink can be filled in 4 minutes and drained in 6 minutes. if the sink is being filled and drained at the same time? In how many minutes will the sink start to overflow? It's also the same number of minutes as when it's completely filled. So for one brief instance, it's filled, and then the next moment it starts to overflow. If we do that little thing on the calculator, notice they're working against each other, so I would subtract. So 4x to the minus 1 minus 6x to the minus 1, enter. Then x to the minus 1, 12 minutes. So in 12 minutes, the sink will start to overflow. Let's see if we can get 12 minutes by doing it the algebraic way. So I will let x equal time to overflow. Can I remember? Invert individual times. So I'm going to have 1/4 x minus 1/6 x equals 1. The minus because they're working together. One is filling, one is draining. Common denominator for 4 and 6, 12. So multiply everybody by 12. 12 over 4 is 3, 12 over 6 is 2, and don't forget 1 times 12. So I have 3x minus 2x equals 12. The equation just solved itself. X is 12. 12 minutes. The exact same thing our calculator gave us. So again, when the individual times are given as numbers, you can do that on the calculator. Number 3. Working alone, it takes pipe A 3 hours longer to fill a tank than it takes pipe B working alone. So notice I'm not given actual numbers, so I cannot do that thing in the calculator. Working together, the two pipes filled the tank in 6 hours. How long would it take each pipe working alone to fill the tank? Your answer may be a decimal number. If necessary, round to the nearest hundredth of an hour. Okay, hundredth is 2 decimal places. So in this one, I'm given the time together, and I'm looking for the individual time. Okay, I'm comparing two things, pipe A and pipe B. Remember, typically, the one mentioned second is going to be x. So it says, working alone, it takes pipe A 3 hours longer to fill a tank than it takes pipe B working alone. So in the comparison, pipe B is mentioned second. So x will equal the time for pipe B alone. Now, according to the problem, pipe A is 3 hours longer. So x plus 3 is the time for pipe A working alone. Now remember, we're going to flip those over and multiply by the time together. Together, it's 6 hours. And they did, in fact, work together, so I'll be adding. So I'm going to have, as my equation, 1 over x times 6 plus 1 over x plus 3 times 6 equals 1. Okay, let me put these 6's in the numerator. So 6 over x plus 6 over x plus 3 is equal to 1. And again, the 1 stands for one completed task. In this case, one filled up tank. My LCD is x times x plus 3. Okay, remember, multiply each numerator by a factor from the LCD that are not in its denominator. So I have 6 times x plus 3 plus 6x is equal to x times x plus 3. I have to distribute. I'll have 6x plus 18 plus 6x is equal to x squared plus 3x. I want to combine some terms. On the left, 6x and 6x is 12x. So this is the last line from the previous. So I have 12x plus 18 is equal to x squared plus 3x. Okay, it's got an x squared. I'm going to move it all to the right. Subtract 12x, subtract 18. So 0 is equal to x squared minus 9x minus 18. It doesn't factor. Okay, it doesn't factor. We've got to use the quadratic formula. So my a is 1, my b is negative 9, my c is negative 18, and there's my quadratic formula. Plugging in the numbers, I have negative 9 plus or minus square root of negative 9 squared minus 4 times 1 times negative 18 all over 2 times 1. We crunch, crunch, crunch. We get 9 plus the square root of 153 over 2. Okay, it looks like it's going to be necessary to round. Now, again, if I gave this to the calculator, probably could have gotten to the very beginning here. So, open parenthesis for the numerator. I'm going to do the plus one first. 9 plus second square root. This one did not open the parenthesis. So 153. Get out from under the square root. Close for the denominator. Numerator. Divided by 2. Okay, to the nearest hundredth, I'm getting 10.68. Now what about the minus? Could there be 2 times? So I want to edit it. Second, enter. go and change that plus to a minus. Negative time doesn't make sense. So to the nearest hundredth, it looks like 10.68 hours. So the negative time doesn't make sense, that's why I'm throwing it out. So about 10.68 hours. Remember, that was for pipe B. Pipe A is 3 hours longer. X plus 3 is 13.68. Okay, now if you were asked for the exact time, this would be it. That would be the exact time. 9 plus 41, 53 all over 2. So pipe A alone takes about 13.68 hours. Pipe B alone takes about 10.68 hours. Problem number 4. I've always called this the ski trip problem. A group of friends have decided to split the cost of a ski trip. The total cost of the trip is $1,485. Susie and John have changed their minds and decided not to go. Always happens, right? Always someone screws it up. Each person now has to pay an additional $30. How many people were in the original group? Now be aware, sometimes you'll be asked how many people actually went. So $1,485 total cost. Okay, I'm going to let X equal the number in the original group. Okay. Now without Susie and John, so I've lost 2 people. X minus 2 is equal to the number without Susie and John. Okay, the idea when you split the cost of a trip or anything, you take the total cost divided by the number of people. So 1485 over X is the original cost per person. Okay, and 1485 over X minus 2 is equal to the cost without Susie and John. Okay, now the question is this additional $30. Okay, so each person now has to pay an additional $30 without Susie and John. So the cost per person without Susie and John is an additional $30. So without Susie and John, the cost per person is $30 more than with them. So remember, 1485 is without them. 1485 over X minus 2 is without them. 1485 over X is with them. So my equation is 1485 over X minus 2. So that's, excuse me, that's the cost without Susie and John is, there's my equal sign, $30 more than, plus 30 on the end, with them. Remember, 1485 over X was with them. There's your equation. Remember, the verb of being is the equal sign. My LCD is X times X minus 2. Okay, we're going to multiply each numerator by factors from the LCD that are not in its denominator. Notice the 30 has a denominator of 1, so it's going to be multiplied by both factors. So let me start over here. So remember, this is where we left off. So 1485 times X is equal to 1485 times X minus 2 plus 30X times X minus 2. I'm going to have some huge numbers here. I got to distribute the 1485 and I got to distribute the 30X. So I have 1485X is equal to 1485X minus 2,970 plus 30X squared minus 60X. If you'll notice, 1485X equals 1485X plus a bunch of other crap. These 1485X's have the same sign on opposite sides of the equation. They add out, so I can eliminate them. So 0 is equal to 30X squared minus 60X minus 2,970. Okay, I put what was left in correct order. 30X squared minus 60X minus 2,970. It turns out all these numbers can be divided by 30. So I factored out the 30. I now want factors of negative 99 that add up to be negative 2. It looks like 11 and 9, and the 11 gets the minus sign. So 30 times X minus 11 times X plus 9. Okay, 30 can't be set equal to 0. If you set X minus 11 equal to 0, you get 11. If you set X plus 9 equal to 0, you get negative 9. Okay, you can't have negative number of people. So negative 9 doesn't make sense for the word problem. So X is 11. There are 11 people in the original group. Okay, notice, without Susie and John, there's 9. The absolute value of the one that got rejected. So anyway, 11 people in the original group. And if you were asked how many people actually went, 9 people actually went. Number 5. Another motion problem. Okay, we had those a long time ago. We made a table. We'll do the same thing here. A boat can travel 16 miles per hour in still water. A 240-mile trip upstream takes 8 hours longer than the return trip downstream. Find the speed of the current. Okay, the speed of the current is sometimes called the speed of the river or speed of the stream or something. So it's 60 miles per hour if nothing is pushing it or pushing against it. A 24-mile trip upstream takes 8 hours longer than the return trip downstream. Remember, when you make the table, typically one column has the same entry for both rows. Okay, so I'm going to let x equal the speed of the current. When the boat travels downstream, okay, the current is pushing the boat. So it's boat plus current. Notice if you get it backwards, it's the same thing, current plus boat. But when the boat travels upstream, the current takes away from the boat. So the rate is boat minus current. Notice with the subtraction it matters, but do notice it's alphabetical order. Boat minus current, boat plus current. Okay? Let's make our little chart. Oh, by the way, the same thing happens when you're doing an airplane in a tailwind or wind or something like that. It's airplane plus wind when you're going with the wind. It's airplane minus wind when you're going against the wind. Again, notice it's alphabetical order. So if you make the table, a downstream trip and an upstream trip, I got distance, rate, and time. And again, remember, there should be typically one column that has the same entry for both rows. Okay, now according to the problem, a boat can travel 60 miles per hour in still water. That doesn't help. A 240-mile trip upstream. Okay, so there's the distance upstream, 240. Takes 8 hours longer than the return trip upstream, downstream. Notice it's the return trip. So downstream should be also 240 miles. Okay, also inside of there was something about time. So it says the return trip downstream takes 8 hours longer, okay, than the upstream trip then. So the upstream trip takes, there it is, the upstream takes 8 hours longer than the return trip downstream. So if I call downstream T for I don't know, the upstream is 8 hours longer, T plus 8. Okay, now our rates. Okay, a boat can travel 60 miles in still water. Okay, so I'm looking at boat plus current, boat minus current. Let me call the current R just for lack of a better name. So when you're going upstream, remember it's boat minus current, 16 minus x. And when you're going downstream, it's boat plus current, 16 plus x. There's my table. Remember, each row writes an equation. So I have 240 is equal to t times 16 plus x. This row gives me 240 is equal to 16 minus x times t plus 8. Okay, this is a nasty problem. It's not super nasty, but it's nasty enough. Okay, I don't really care about the time. It would be great if I knew it, but I don't really care about it. It's not asking for it. It's asking me for the speed of the current. It's asking me for x. So I look at these two equations, and I ask myself, which one of these two equations would be easy to solve for t? Which one would be easy to get t by itself? This one, because this one's got t inside of parentheses, and I got to do all kinds of distributing nonsense. So I'm going to take this top equation right here and solve it for t. So I have to divide by 16 plus x. So we're going to solve the first equation for t. So 240 over 16 plus x is equal to t. Okay? Again, we picked it because it was very easy to do. Because remember, I don't care about the time. It would be great if I knew it, but I don't care about it. I now take this value of t, 240 over 16 plus x, and put it right here. Okay? So I'm going to replace this t with 240 over 16 plus x. Okay, I just got rid of the statement of the problem. That's all I did. I got rid of the statement of the problem. So we substitute this value of t into the second equation. Okay, and this is going to be messy. I've got 240 is equal to 16 minus x times 240 over 16 plus x plus 8. Okay? Now, just to let you know in advance what we're about to do, because it's going to look nasty. On the right-hand side, I'm just going to FOIL. First, outer, inner, last. Okay, the left-hand side remains 240. So I'm about to do FOIL on the right-hand side. So I'm going to have 240 equals, okay, 16 times 240 over 16 plus x, right? That's the first. Okay, that's a times, not an x. Okay, then now I do my outer, 16 times 8. My inner minus 240x over 16 plus x. And my last minus 8x. FOIL. First, outer, inner, last. Okay, I got some multiplication to do. 16 times 8 and 16 times 40. So I'm going to have 240 is equal to 3,840 over 16 plus x, plus 128 minus 240x over 16 plus x, minus 8x. Okay, I need to make the denominator go away. My LCD is 16 plus x. I got rid of the table, in case you're wondering. I got rid of the table. So my LCD is 16 plus x. So I'm going to clear fractions. So I'm going to have 240 times 16 plus x is equal to 3,840 plus 128 times 16 plus x minus 240x minus 8x times 16 plus x. Okay, I told you this is going to be a bad problem. Looks like I have some more distributing to do. Okay, distribute the 240 on the left, and I'll distribute the 128 and the minus 8x. I'm going to have 3,840 plus 240x is equal to 3,840 plus 2,048 plus 128x minus 240x minus 120x minus 8x squared. Okay, now I look for things that can go away. Okay, I've got 3,840 on both sides of the equation with the same sign. They add out to be 0. Now the 240x's, they're on opposite sides, but they also have opposite signs. I can't make them go away. Okay, on the right, 128x minus 128x will go away. So I've eliminated those. So let's see, what will be left with? 240x is equal to 2,048 minus 240x minus 8x squared. Okay, I got an x squared term. I want to set equal to 0 and try to factor. Again, I cannot think with negative squared terms. I'm going to move it all to the left. So I'll have 8x squared plus 480x minus 2,048 equals 0. All of these numbers, 8, 480, and 2,048, can be divided by 8. I'm now looking for numbers that multiply to be negative 256 and add up to be 60. It turns out it's 64 and 4. Okay, so this was the last line of from the previous slide, right? So I have 8 times x plus 64 times x minus 4. I get negative 64, 4. Okay, negative x doesn't make sense. You can't have a negative speed. So x is 4. So the current is 4 miles per hour. Okay, now that probably was our most hideous word problem in terms of solving it. Let's try one more motion that's not quite so horrible. An airplane, maintaining a constant airspeed, takes as long to go 450 miles with the wind as it does to go 370 miles against the wind. If the wind is blowing at 15 miles per hour, find the speed of the plane. So I've got a with the wind and an against the wind. I'm going to let x equal the speed of the plane. Now, negative x's won't make sense. Okay, I make my table. Okay, so distance, rate, time, with wind, against wind. Okay, now looking at the problem. It says an airplane maintaining a constant speed takes as long to go 450 miles with the wind. Okay, there's the distance for with the wind, 450. As it does to go 370 miles against the wind. Okay, there's the distance for against the wind, 375. Now also contained inside there was something about time, right? An airplane maintaining a constant airspeed takes as long to go 450 miles with the wind as it does to go 730 miles against the wind. It takes the same amount of time. So with the wind and against the wind are both t. Okay. Now we've got to figure out our rates. So let's see. The wind is going at 15 miles per hour. Remember, when you're going with the wind, it's airplane plus wind. So it's going to be x plus 15. When you're going against the wind, it's airplane minus wind, x minus 15. Okay? There's our table. Remember, each row of the table writes an equation. So 450 is equal to t times x plus 15. This one says 375 is equal to t times x minus 15. Okay, now, in the previous example, we said let's find the equation that's easy to solve for t, because remember we didn't care about t. In this equation we also don't, or in this problem we also don't care about the t. It would be great if we knew it, but we're looking for the speed of the plane. So we pick an equation that's easy to solve for t. They're both easy to solve for t. Solve both of them for t. So we solve each equation for t. Okay, for this one divide by x plus 15, and for the second one divide by x minus 15. So I have 450 over x plus 15 is equal to t, and 375 over x minus 15 is equal to t. So both of them were easy to solve for t, so we solved both of them for t. Remember, it's the same time. So these two expressions on the left are equal. So 450 over x plus 15 is equal to 375 over x minus 15, because remember, they're both the same t. Okay, my LCD is x plus 15 times x minus 15, or again, students say, can I just cross multiply? Okay. 450 times x minus 15 is equal to 375 times x plus 15. I have some distributing. 450x minus 6,750 is equal to 375x plus 5,625. Okay, variables to the left, numbers to the right. Subtract 375x, add 6,750. You get 75x is 12,375. Divide by 75, so x is 165 miles per hour. The plane is traveling at 165 miles per hour in still air. That's the end of section 3.4.